Hello. In this video, we want to look at an application. A company determines that the cost in dollars to manufacture X cases of a DVD is given by C of X equals 100 plus 15X minus X squared, where 0 is less than or equal to X is less than or equal to 7. We want to find the average rate of change of cost per case for manufacturing between 1 and 5 cases. In other words, it wants to know what's the slope of the line connecting C of 1 and C of 5, basically. So here on A, we really just want to find the average rate of change there. That's really all it's asking for. So the ARC, average rate of change, will be C of 5 minus C of 1 all over 5 minus 1. And then you just figure out what these are. We need to figure out C of 5 and C of 1. Notice that C of 5 just means I replace all of the x's with a 5. So it gives me 100 plus 15 times 5 minus 5 squared. 15 times 5 is 75, so that's 175 minus 5 squared, which is 25, so 175 minus 25 is 150. Next, let's look at C of 1. So that's 100 plus 15 times 1 minus 1 squared. 15 times 1 is 15, 1 squared is 1, so 115 minus 1 is 114. Excellent. So just replace C of 1 with 114, replace C of 5 with 150, and simplify. So it gives us 150 minus 114 all over 4. Now, if you notice, 150 minus 114 is going to be 36. So this is 36 over 4, which is just 9. So the average rate of change here will be 9. Now, what are the units here? Notice that the cost is in dollars. So we have dollars for that per something. And what is X in? Well, X is the number of cases. So dollars per case. In other words, the average rate of change for going from 1 to 5 cases is $9 per case. Basically what that means is that if you started out with 1 case and then you increased your production to 5 cases, then the average cost for each one, the change from going from one to the other, is going to be $9 per case. Now, this isn't going to be that if it goes from 1 to 6 or 1 to 7 or anything like that, because of the fact that average rate of change takes into account for both the first and the last. Alrighty. Letter B. We want to find the average cost when production is increased from 1 to 2 cases. Now this is kind of interesting because this is going to be another average rate of change from 1 to 2 cases. We already know C of 1. What we need to figure out for this one is we need to figure out C of 2. So C of 2 will be 100 plus 15 times 2 minus 2 squared. 15 times 2 is 30, plus 100 is 130, minus 4, 130 minus 4 is 126. Notice again that we already know that C of 1 is 114. So the average rate of change here is simply going to be C of 2, which is 126, minus C of 1, which is 114. Then all over 2 minus 1. And then just simplify. 126 minus 114, what is that? 12? So it's 12 over 1. So the average rate of change will be $12 per case. Awesome. But that's going from 1 case to 2 cases. Okay, now notice that up here, the average rate of change is a little bit lower, going from 1 cases to 5 cases. Now, if we look at this, letter C says to find the instantaneous rate of change of cost with respect to the number of cases produced when just 1 case is produced. So for this one, we want to say the instantaneous rate of change with just 1 case. In other words, when x is equal to 1. To do this, we're going to need to know a couple of things. We need to know that C of 1 is, first of all, we already know that to be 114. Good. What we also need to figure out is what is C of 1 plus h, because we're going to need to know that. Plugging in the 1 plus h in for all the x's is going to give us 100 plus 15 times 1 plus h, and then minus parentheses 1 plus h squared. Simplifying, we get 100 plus 15 plus 15h, and then minus in the big parentheses because we need to go ahead and square this before we distribute the negative. Doing so, that's going to give us 1 squared of 1 and h squared of h squared. So those are the first and last terms in there. Now we need the middle term. 1 times h is h, and then double it makes that 2h. So plus 2h there. Excellent. And then we can distribute the negative, making this 100 plus 15 plus 15h minus 1 minus 2h minus h squared. Awesome, and then just combine like terms. I'm going to try to go in descending order here, making this negative h squared, that's that first term, and then 15h minus 2h is 13h. And then 100 plus 15 is 115, minus 1 is 114, so plus 114. Good. Which is what this is, and that's actually helpful. So this tells us that C of 1 plus h is actually equal to negative h squared plus 13h plus 114. The reason that this is helpful is because the instantaneous rate of change is going to be the limit as h goes to 0 of C of 1 plus h minus the C of 1 all over h. Awesome. Now, just plug in everything that we know here. C of 1 plus h is all this. C of 1 is right here, so plug in that for this, and plug in that for this. This is going to give us the limit as h goes to 0 of negative h squared plus 13h plus 114, and then subtract off the 114 there. Awesome, and then all over h. Good. Now notice 114, they cancel each other. And also notice that in the numerator we have an h and an h in common. There may be more than one of the h's in common, or there may be more than one, there may be more than just the h in common, but that doesn't mean we need to factor it out. All we need to worry about right now is just the h that's in common. So let's do that. So this is going to give me the limit as h goes to 0 of h times, now remember, we're just dividing these terms by h, so we're left with negative h and then plus 13 all over h. Excellent. And now notice that those two h's will in fact cancel each other, and that's going to leave us with the limit as h goes to 0 of negative h plus 13. Then, of course, plug in 0 for the h and simplify, and that's going to give you 13. So the instantaneous rate of change is going to be $13 per case. That's when x equals 1. Now, here's the thing. While we've answered all these questions, I do want to emphasize one thing. Notice that going from C of 1 to C of 2 is going to give us an average rate of change of $12 per case. But notice that we're just adding 1 to the x. Remember, we have a term that is called marginal cost. Marginal cost is defined. Now I'm going to start using these mathematical symbols. 3, kind of like an equal sign, but not really an equal sign, means defined. So marginal cost is defined as the cost of x plus 1 minus the cost at x. In other words, it's the difference between 1 to the next one. In other words, from 1 to 2, from 2 to 3, and so on and so forth. So the marginal cost at x equals 1 is going to be $12 per case. But notice that the instantaneous rate of change at x equaling 1 is $13 per case. They're not the same thing. But if we start using kind of larger values of x, say even x equals 5, x equals 10, even once we get to there in this case, the difference between the marginal cost and the instantaneous rate of change will start to be very, very small. And that's actually one of the important things in all of calculus, is that the marginal, whatever it is, can be thought of as an instantaneous rate of change. Now, as I said, it's not exactly the same, but it's going to be pretty dang close, especially once we start really working with more real-world situations. Alrighty. And by the way, marginal cost is C of x plus 1 minus C of x. Marginal revenue would be R of x plus 1 minus R of x. And marginal profit would be P of x plus 1 minus P of x. It's always the either cost to produce one more, or it's the revenue extra that you get from making one more, and it's also the profit that you get from producing and selling one more. It's always just one more. Alrighty, well, I think I'm going to go ahead and end it here, and I will see you in the next video. Have fun.